Good day to all. This is Krishna Raj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology. In this video, we are going to be discuss about automotive engine component design and what are the design parameters should be followed for it. Before going to this subject, so what is the course learning objective for this subject? To build the students understand the design concepts of various engine components like cylinder, piston, connecting rod, crankshaft, flywheel and valve mechanism. To understand the energy conversion of engine. To develop the students familiar in balancing of rotating masses. To make the students to understand the motion study of rotating components. To make the students to design the engine components according to the engineering materials and its relative conditions. Engineering materials and their properties. The knowledge of material and their properties of great significance for design engineers. The machine elements should be made of such as material which has properties suitable for the conditions of operation. In addition to this, a design engineer must be familiar with the effect of the manufacturing process and the heat treatment have on the properties of material. In this video, we'll discuss commonly used engineering materials and their properties in the automotive engine components. So the first one is the classification of engineering materials. So metals and their alloys such as, so the metals such as called as an iron, steel, copper, aluminum are called to be as an metals, right? So on this metals, so it is furtherly classified as an ferrous and non-ferrous materials. So ferrous materials are those who have iron as their main constituents. So ferrous materials have the iron as their main constituents, and so the example for the ferrous material is rough iron, steel, or the non-ferrous materials such as, so other than that metals as their main constituent, like in copper, aluminum, brass, zinc are the non-ferrous materials. Then the second classification is non-metals. So non-metals other than that metal compounds like such as glass, rubber, plastic, wood, these are all called to be as an non-metals. So other than that of this metal components. So it is a non-metals. The next is selection of material for engineering purposes. The selection of proper material for engineering purposes is one of the most difficulty problem for design engineers. So the best material is one which have serve desired object at minimum cost. So the following factors should be considered while selecting of the materials. So the first one is availability of material. The availability of materials includes, so the location and where it is easily available. So based on that, so the selection process will be there. So where the material availability is there. For example, if you take in an iron materials, so Jamshedpur in India, Jamshedpur it is easily available. So the raw material availability is an important thing for the selection of materials. So while designing this, so the first primus thing is availability of material. Then second one is suitability of material. So the suitability of material for working condition and its services. So whether that material is suitable for working condition and foreign services. So it is perfectly suitable or not. So for a particular component, so the suitability of material is varied. It can be manufactured by gunmetals or non-gunmetals, whatever may be. You have to choose that right suitability material. Then third one is cost of material. So the cost of material plays a vital role in this. So the cost effectiveness. So while producing a component, you need to produce an cost effective products. So it should not be in too much of cost. That includes a lesser cost. So the raw material availability, suitability, everything that includes of this cost parameter. So the right example, we can say that Tata Nano. Okay, so the example for this selection of material is successful of product is Tata Nano. So whether it is possible to produce an Tata Nano 1 lakh, yes, it is possible, can, right? So the Tata Nano can able to sell rupees 1 lakh, even though the vehicle two-wheeler cost is around 1 lakh. So they sell an Tata, they sell an car 1 lakh rupees. How it is possible now? So they are mainly concentrate on the material properties and like an selection of materials. So the availability of material, suitability, cost, and everything, so that only they can able to sell and product an exact 1 lakh rupees. The next is physical properties of material. On this physical properties of materials like an luster, color, size, shape, density, electric and thermal conductivity, and the melting point. So on this physical property, so the physical measurements like an mass of this property, density, color, length, okay, pressure. So like in physically visibly measuring properties that are called to be as an physical properties, like whether it is color, so it looks like an which color is suitable for this, while producing an vehicle, so the color is an important product, and the mass of this. So everything that includes on the physical properties. Then next thing is mechanical properties of metals. So it is a very important property of the metals. So while selecting of this, so the mechanical properties of metals includes, so the first one is strength is an first mechanical property. It is the ability of material to resist the externally applied force without breaking or without yielding. So this is called to be as in strength. Without breaking, when the external force is applied, this ability is called as in strength. Then second one is stiffness. It is the ability of material to resist deformation under the stresses. So it has some stiffness over there. So it has some deformation when applied in forces. This property is called as an stiffness. Then third one is an elasticity. So elasticity is the property of material to regain its original shape after deformation when the external forces are removed. When forces are applied, it will deform, and when the forces are removed, external forces are removed, it again regain to the original shape, like in elasticity. Then next one is in plasticity. It is the property of material which retain the deformation produced under the load permanently. When external forces are applied, it deforms, and the load is removed, it permanent deformation is there. That property is called as in plasticity. The next is in ductility. It is the property of material enabling into as an drawn into as an wire with the application of tensile force. So like in a gold chain, everything is a property of ductility. When the external force is applied, it is drawn into be as an wire. So it is a gold chain, it is a very good example. The next is in brittleness. It is the property of material opposite to ductility, that is when the breaking of material occur, there is no little bit deformation. So it is a permanent distortion is there is no deformation occur in the brittle material. The next is in malleability. Malleability means, so it permits material to be rolled or hammered into as in sheets. So we can form as in sheet metal works. That kind of things is called as in malleability, like in chopped steel, rough iron, copper, aluminum. That has a property of malleability. The next is a toughness. It is the property of material to resist fracture due to high impact loads like in hammer blows. So it resists the fracture when the high impact forces are occur. So the very good example is like if you are taken into this leaf spring and others. The next is an machinability. So it is the property of material which reforms to the relative cases with the material can be in cut. That means we can machine into desirable shape. So what we need and desired shape. So the material has the property to machine into this. Then next is an resilience. It is the property of material to absorb the energy and to resist the shocks and impact loads. So it absorbs the energy. For example, if the leaf springs are taken into this, so continuously road shocks are there, so it will absorb the property that it has a resilience. Then creep. Creep is nothing but subjected to an constant stresses at high temperature for a long period of time. It will undergo and slow permanent deformation. Then it is called as a creep. So the next is an fatigue. When the material is subjected to repeated stress, it fails at an stress below the yield point stress. Such a type of failure is called as a fatigue stress. So if you are continuously blowing on the metal, then that is called as a fatigue load. Then last one is an hardness. It is a very important property of the metal. It has a wide varieties of meaning. It is nothing but it is a resistance to wear, resistance to scratch, resistance to deformation, resistance to machinability. It is called as an hardness. It is the ability of material to cut into another metal. Thank you.